Hi everyone, so we're going to start our next unit talking about water in a more specific general sense here. So as you know, water, we're going to talk just a little bit about the water cycle here. So as we look at our water cycle, we know that we have terms like evaporation, where water is going to go from the oceans or lakes into the atmosphere. We have condensation, where that water vapor that was evaporated is going to condense into these clouds. Precipitation, which is that water in some form, either frozen or liquid, coming back down to the earth. And those are going to be the big three terms that are going to be brought up multiple times in this unit. So those would definitely be ones that I would circle, write down on your page right now. So let's talk about the Earth. Our Earth would also be considered our water planet. Water covers about 71% of the Earth's surface. So because of the depth, the volume of the Earth's oceans, it provides more than 99% of the biosphere, which is this habitable space on the Earth. So our biosphere is a combination of both land and our oceans. But since the oceans have this huge availability for both depth and volume, and they already cover about 71% of the Earth, 99% is going to be that biosphere here. So, in a vast majority of Earth's water actually can't be used directly. So because of the salt water, we can't use it for drinking, irrigation, or industry until we have either purified it in some way or altered it. Though there is some water that is purely good for those things, usually that water is going to be found in our freshwater ecosystems or our groundwater. So let's talk about our water molecule itself. It is made up of 2 hydrogens and 1 oxygen. And we can see that over here. Our oxygen is going to be our larger atom, and we have our 2 hydrogens on the side. And these are all connected by what we call covalent bonds. And what that means is that we can see that these electrons here are going to be shared between the atoms in the molecule. So our hydrogens and our oxygen share these 2 electrons to balance out these compounds here. And because of that, because hydrogen is a much smaller atom than oxygen, the sharing is uneven, giving it a negative side and a positive side here. So the oxygen is going to keep more of the electrons. You can see it has 1, 2, 3, 4, 5, 6 to itself, and it's only sharing these 4 with the hydrogen. So it's going to take on this more negative charge. And because we have one side that's more negative and one side that's more positive, this is going to be called a polar molecule. So as a result of this polarity, we're able to have these water molecules be attracted to each other. So the negative side of the water molecule is going to be attracted to the more positive side of other water molecules, as we can see here. So that's how it's going to be attracted. And these green lines here represent hydrogen bonds. And that is how water is held together. So because of this polarity, water has some really unique characteristics. And we can see that with these hydrogen bonds connecting all these water molecules. And since these are being connected, we come up with these really specific properties. One of them being liquid at room temperature, but also these other words here. Cohesion is our first one. So cohesion is water molecules sticking together, and that's going to be due to these hydrogen bonds that are forming between the positive and negative ends of our water molecule. We also see adhesion. So this means water can stick to other surfaces like drinking straws, Adhesion's a really important concept when we're talking about plants and how water reaches really, really tall plants. And then we also see this other one called surface tension. So a skin is kind of formed on top of the water, creating resistance from objects from penetrating it. So if we take a look at our bug here, this little skin on top of the water, because that water is being held together by cohesion in those hydrogen bonds, unless an object is strong enough to push through those hydrogen bonds, it will stay on the top of the water like this bug is. Hydrogen bonds are very weak though, so it's pretty easy for us to break those hydrogen bonds and get through those water molecules. But in the small chances like this bug, or like, say, if we put a piece of styrofoam on top of water, you would see that surface tension preventing it from sinking into the water. Another really interesting fact about water is that our ice floats. It's less dense than in a solid form than it is in liquid form. And this is a really unique property because most things in its solid form are less dense, are more dense than in its liquid form. So this is because when water cools from a liquid into a solid, our bonds between the water molecules are going to spread out, and it makes this crystal structure take up more space than our liquid structure. So because it's taking up more space, that's why water expands when it's frozen. It allows it to become less dense in a fact. Most things, when they are frozen, become more dense because all those water molecules are getting closer together, allowing more water to fit in a smaller amount of area when it's a solid. Another reason this is a really important concept is because if ice sank, our oceans could either be entirely frozen or substantially cooler. And this is really important because our oceans do absorb so much of the heat that comes from the sun. It helps regulate our global temperature. And since our global temperature would be cooler, it might be too cold for life to exist on Earth itself. Last thing we're going to talk about today is the salinity of water. So we know that most of the water on Earth has some sort of salinity to it. And a salinity is the total amount of all dissolved inorganic solids in seawater, so not just salt here. Though sodium chloride, which is salt, is going to be the most abundant one that we will see. We usually see a salinity measured in parts per thousand, and the ocean salinity can vary from either 5% parts per thousand in a river mouth, so in our estuaries, to more than 40% in a confined, very arid regions of our oceans that have the most amount of these dissolved inorganic salts. But about average salinity in our oceans is going to be 35 parts per thousand here. That's where we're going to end today. If we have any questions, make sure we reach out and ask.